All right, welcome guys. We are doing the 11/8 flipped homework here, which is your homework for tonight. So this is on similarity proofs in circles. So yesterday we took a look at our circles. We went through some reasons and stuff that go with the circles. So today we're going to take a look at just similar triangles. So number one, question one. So let's just review 3 ways to name the triangles are similar. So the first way, remember, there's angle, angle, or also known as angle, angle, angle. You only need 2, but you can do all 3. So if 2 sets of angles and the triangles are congruent, then the triangles are similar. Remember, if you get 2, you can get the third because they all add to 180. Number 2 is side, angle, side. This means that there's 2 sets of corresponding sides that are congruent, and the angle in between is also congruent. That shows similarity. So not all of them are equal to each other. The 2 sides are actually, these are proportional, right? 2 sides proportional. The angles in between are congruent. And the third one is side, side, side. You have to show that all 3 sides are proportional. You need to make an extended proportion. So something over something, right? You do extended proportion to show that those are equal, and you're good to go. Okay, so number 1. In the diagram below, we have 2 triangles. Below AE and BD intersect at C, we know that angles CAB and CED are equal. What method can we use to show? So we can get these 2 vertical angles equal. So you're always looking for something else in the diagram that we can get here. Also, if these 2 angles are congruent, we can show that these 2 lines are parallel, which means these 2 angles are also going to be congruent. So we can do angle, angle here. These 2 are for congruence, so they definitely can't be used. And we don't have any sides proportional, so number 1 would be out. All right, number 2, angle DRS is congruent to ART. We have the 45, 15, 36, and 18. So we want to know, are they similar, and if so, what method? So we definitely know that there's not 2 sets of congruent angles. So number 1 is out. And we don't have all 3 sides, so number 3 is out. So it's either side, angle, side, or not similar. We need to check our proportional. What I'm going to do is pick a side from either triangle and set up a ratio. So let's say, for instance, we take 36 and we put with 15, because these are the 2 smaller. So is 36 over 15 equal to these 2, right? 45 over 18. Now, if you have a calculator, you can just put them equal to each other and hit enter, and it will reduce it for you. Grab one real quick, and I'll show you. So, add a calculator, 36 over 15, enter, is 12 over 5, okay, is 45 over 18, the same thing. How about 45 over 18, yeah. And we can see it's 5 over 12, so it's 5 over 2, so it's not the same. You can also do 36 over 15 this way, put an equal sign down, and then do 45 over 18, and it will tell you if it's true or false. And here it says false. So these are not similar, because these are not equal. Okay? Number 3 is for which diagram is the similar triangle not always true? So this is always true because these share angle A. So this is true because of angle, angle. The number 3 has the vertical angle, so this is also true because of angle, angle. Remember, we're looking at ABC and ADE. So ABC and ADE. And this is true because of angle, angle. Here's ABC and ADE. And this one we don't know is true. And the reason why is because in these 2 triangles, I have 1 set of angles congruent, and I don't have anything else. I don't know that this is isosceles, which rules out the fact that these sets of angles are going to be congruent. We can kind of do some stuff. We could get this angle equal to this angle, but that's as far as we really can take it here. And those angles aren't even in the triangle. So we're kind of stuck at this point. So this one would be the one we want to choose. Number 4, which is not true. So If angle ABC is similar to RST, that means that the angles and those letters, how they line up, are all equal. So angle A is congruent to angle R, angle B is the same as angle S, and then C would be the same as T. Which statement is not true? So is A the same as R? Well, yeah, we marked it down, right? Not true, so that's out. Is AB over RS, so AB over RS, so that's the bottoms, okay. And it goes from left to right, the same as BC over ST. So left to right, left to right. That is true, okay? So that one's out. What about AB over BC, right? So this is bottom to right, bottom over right. RS to ST, bottom over right. Oh, AB, right? Oh, ooh, look at this one. Bottom, right, over right. And this one is right over bottom. So that's not the same order. So this is actually not true. So this is one we would want to pick. And we can check the other one. Because this plus this plus this, right? So this question is, are the perimeters, IME, equal to the sides? Does the ratio of the perimeters equal to the ratio of sides? And the answer here is yes. So we would want to choose choice 3 because this ratio is in the wrong order, the corresponding side. Okay, so just a quick review over congruent triangle proofs, and what we should know is that this is letter T and it's not showing up, so just be aware. All right, so in the diagram below, we can do the little proof. So T-chart, statements, reasons. So we know that GI is parallel to NT, and we know that IN intersects GT at I. And that's the givens, okay? So we know that GI is parallel to NT. So what do we know? Well, we can actually do this in 3 steps, and we could do an optional step to get it in 4. We'll go over them. So we should know parallel lines, we're looking for the Z's and E's. There's a Z going this way, so angle I is going to be the same as N. And there's one going the other way, a little backwards the action here. And that's going to make these 2 sets of angles congruent, okay? So we can say angle I is congruent to angle N, and angle G is congruent to angle T. This is going to be our 2 parallel lines cut by a transversal. Question, the alternate interior angles are congruent. All right, we could end the proof right there. That's it, right? So now we have 2 sets of angles congruent. We can say that triangle GIA is similar to triangle TNA. So this one is just going to be angle similarity. For a proof, 90% of the time, 99 almost, you're going to be using angle. Unless the given has a ratio in it. Okay, that's going to be the only thing that kind of might throw you off there. And that's it. Now, the optional step is you could do the vertical angles, right? We could say angle IAG is congruent to angle NAT, and this would just be vertical angles are congruent, and we could call this like 2.5 here. You could throw that in there for another set of angles. So we could do one of these 2 sets with the vertical angles, or just the and then you're good to go. Okay, and number 6. So we have a parallelogram. So once again, statements, reasons. Now, because we know this is a parallelogram, we know those 6 properties of a parallelogram are going to be in play here. Okay? Which is opposite sides are parallel, opposite sides are congruent, one pair of sides is congruent and parallel, diagonals bisect each other, all those lovely things. So, key thing, we want to get triangle DEF. So remember, highlight your triangles so you know what we're looking at. DEF and BFG, and then label anything they tell us. So in the given it says That's a parallelogram that helps us. We don't really have anything else. We know that that's a diagonal. Now, we can't use the diagonals bisect because this is not a diagonal. So we can't say that these sets of lines are equal. So remember, we're trying to get angle, angle here. So does anyone see a set of angles? Good. Hopefully you said vertical angles, right? Okay, I feel like I'm like doing a Disney Junior here. You see this? Yeah, okay. All right, back to my play here. So we're going to say that angle DFE is congruent to angle, and then we got going the other way, right? Angle BFG, and these are vertical angles. So vertical angles are congruent. Now the other set of angles are going to come from our alternate interior angles from these two lines. Because this is a parallelogram, we know that these two lines are parallel to each other, okay? So we know that AD is parallel to BC. So we can say in a parallelogram, and then name the property, right? Opposite sides are parallel, and yeah, there's 3 there. So now that we have number 3, now we can use our alternate interior angles here. So we have 2 sets. You only need 1, but we could skip the vertical angles and just do the alternate interior angle again. So angle EDF is congruent to angle GBF. And then you could throw the other set in there if you want. And once again, 2 parallel lines cut by a transversal alternate interior angles are congruent. And then we have enough to get the triangle similar now. So triangle DEF is squiggly or similar to triangle BGF. It's called the tilde, not a squiggly, by the way. And then this is just angle, angle, similarity theorem. If you put angle, angle with similarity, you're good to go. Okay, so that's number 6. And on to number 7 here. Here's a circle proof. All right. So let's get the statements and reasons down. So we have circle O. We have a diameter. We have tangent. And E is just a point on circle O. And then we have BE, BE parallel to ADC. And that's all in the given. Okay, there we go. So that's marked down what we know. So we have tangent lines, we have BE, BE parallel to ADC. So we're trying to get triangle ABE, which is this guy down here, to be similar to triangle CAB, which is this big guy over here. So if we have these parallel lines, the first thing we're going to look for is our alternate interior angles, and you can see the Z. So we have angle CAB congruent to angle, and here we have EBA. So that's one set of angles congruent, and that's our 2 parallel lines cut by a transversal alternate interior angles are congruent. Okay, what else do we have? So remember, 2 things that are popping up. We have this angle, right, which is a what type of angle? It's inscribed, and the arc that it creates is this semicircle. So remember, one of the properties we talked about on that sheet today is that this angle is going to be 90 degrees, right? So angle AEB is equal to 90. You can also say it's a right angle, so it's up to you. If you want to say it's a right angle, that's fine. And we're just going to say an inscribed angle to a semicircle is 90 degrees, or a right angle, it's up to you. Okay, so now we know this is a right, that's 90 degrees. And the other one that's going to be 90 degrees is this one. Okay, this didn't come up on the sheet today, but it's a tangent chord. All right, so we're going to say angle ABC is also equal to 90 degrees. All right, and it's kind of the same thing. So angle formed by tangent chord is half the arc. And we can just say, so 180 degrees, because that's how much the arc is. So now we know it's 90. All right, and then for the next step, we're going to want to set these two angles equal. So angle AEB is equal to angle, not triangle, ABC. This is just going to be substitution. And then now we have enough to get the triangles to be similar. So triangle ABE is similar to triangle CAB. And this is angle similarity theorem. All right, guys, that's it for today. Thanks for following through. Tomorrow we're doing some similar triangle proofs with circles in class. And then you'll also be given a GA tomorrow, which will be due on Friday. So let me know if you have any questions. We'll make it due Monday. So Friday, if you have questions, you can ask. It'll be due on Monday. So if you're here first, Mr. Z signing off. All right, guys, thanks for helping me out here. Remember, you're going to get into this, get out of it what you put in. So if you're putting in some time, it'll help a lot. If you're just going through the motions, it's not going to be as helpful. So make sure you're committed to this. If you guys are going to buy into this, then we'll get a lot out of it. So come see me if you have any questions. If things aren't making sense, make sure you speak up and let me know. All right, thanks a lot. See ya.